Okay, guys, I'm now looking at this, Alex. Okay, and what we want to talk about today, guys, are numbers and the way we divide them up. They have different classes, different categories. Okay, now you guys have on your notes this little diagram right here. Okay, and this is the diagram of the real numbers. Okay, now we talked about some unreal numbers. What do we call them? Do you remember what we call the unreal numbers? What do we call them, Liam? Imaginary, right? They're not in this group. They're over here. They're in a different category altogether. Okay? Imaginary, just an example of imaginary is the square root of negative 21, right? Because no number multiplied by itself gives us a negative. But so that's in the imaginary class. We've talked about that. Now we're going to talk about real numbers. Okay? Here are the real numbers. Now, guys, we've started, there's even a category inside the whole numbers down here. These are called the counting numbers. Cavemen sitting around, cave women too. Right? They've got a handful of rocks. And the first thing they do is say 1 rock. Okay? The counting numbers start with 1, 2, 3, 4, 5. Those are the very first and basic numbers. We made a big jump when we went from counting numbers to whole numbers. We actually added the number 0, which is a big deal. A number that means nothing, right? But we need it. Okay, that was a big jump. A number that means no amount. Okay, so 0, that's the whole numbers are all the counting numbers plus 0. Okay, now the integers, this is when we started borrowing from people, I guess. The integers are all the whole numbers and their opposites. Right? I have $4, you have negative $4. Those are different things, right? Okay. Now, the rational numbers is when we started breaking up these whole numbers or the integers into smaller parts, just little pieces of a whole, right? Like 2 over 3 or 0.173 repeating, right? Even a number that's repeating, we can write it as a fraction, can't we? Right? Because 1/3 repeats, but we can write it as a fraction. Any decimal that ends in a 0 or it repeats can be written as a fraction. Okay? And that's a rational number. Rational, ratio, right? Ratios are fractions. So any number that can be written as a fraction is a rational number. Okay, so we've dealt with this whole side over here. Those are rational numbers. Here are the irrational. They're just irrational. You can't really even deal with them. Can't talk to them rationally. They're irrational. That's just a little joke. They're really... Did you get that? Okay, thanks. All right, that'll make me feel better. Hey, guys, all the irrational numbers, they cannot be written as fractions. There is no fraction. There is no integer divided by another integer that represents an irrational number. Here are some. Here's an irrational number. It goes on forever. You guys love it, right? We just passed Pi Day, which I won't do. I will not do, right? Because pi does not equal 3.14, and it certainly isn't related to March the 14th. Okay? Pi goes on forever and ever and ever and ever. There's a guy, the world record for pi is, for memorizing digits, is something like 68,000 digits behind the decimal point. They've calculated well beyond 1 billion places, I think, and maybe even 10 billion. I don't know. I don't really care, you know. I mean, I don't want to sort of knock other people's hobbies, but really, guess what? It's going to be another number between 0 and 9, right? So, I mean, why do you keep doing that? But okay, so that's their thing. I don't want to, hassle them about it. But here are some other irrational numbers, and this is a concept that you've got to get down today. If we take the square root of a whole number and we do not get a whole number, then the result is irrational. So for instance, the square root of 12, when we type that into our calculator, what do we get? It's going to be something approximately 3 point blah 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 blah. 3 point what? 4, 6, on forever and ever and ever. It is irrational. There is no fraction that represents that amount.